Okay, I am Kiana. Uh, I have bachelor degree in statistics. Uh, I have known some programming languages such as R and Python, SQL, and these days I'm working on SAS. It's kind of statistical software. Uh, and for my master, I'm going to study data science as my main major. If you have any other question, feel free to ask.
We continue our session. Please share your screen.
Okay, I'm going to talk about totally text mining with R and one project in it. You know, first, when I wanted to start it, Python, I recognized that Python programming language was better in text mining rather than R. But honestly, not only I was fond of R more, but also I really knew it better than Python. So I chose R programming language for my project. First of all, I want to talk about the applications of text mining. There are some application, for instance, sentiment analysis, customer service, chatbots, automatic summarization, machine translation of the text, and detection of scientific and literary fraud. Uh, Honestly, I don't know some of them, but uh, I really like the concept of my project. Uh, and when I did this project, I was in my bachelor degree, and I wanted to found my data sets with APIs. APIs allows you to find, interact, and retrieve various resources. And there are some social media which have this mm, application. For example, YouTube, Twitter, and Reddit. They have live data set, and you can give permission from them to use their live data sets. But unfortunately, I didn't really able to do that. So I was unsuccessful with it. So I decided to work with a CSV file instead, and I download it from Kaggle sites. And my data sets was about tweets in Twitter. Um, our texts have 34,792 rows and two columns. Rows contains text, and columns contains emotions. And About emotion, if I want to talk about that, there were three: positive, negative, and neutral. And I started to work with ggplot package and visualize them. Unfortunately, we can see that people with negative emotion are the least one, and but with positive, the most emotion in our data sets. So, and neutral in the middle. Because of limitation of in our algorithm and its difficulty, I combined positive and neutral emotion together and visualize them like this, and again with a ggplot package. You might interested in looking at the most repetitive word in our data sets. And as you can see, codes in our text, time, day, love, are the most repetitive word. And all of these words repeat more than 500 times, as you can see that. And here we use another package which very good as at visualization. Its name is wordclou package, and here based on the frequently they appear in their size. I mean, the more frequent package, the more size they have. I mean, they're bigger, and maybe we interest in separates negative and positive words. For example, the words which has positive meaning, they appear in green color, and the word with negative meaning, they appear in red color. Love, happy, join, ready. They have all positive meaning. Afraid, hate, angry, bad, scared. They all have negative meaning. Before we start our analysis, we should get familiar with some kind of text type. I know that all of you familiar with string. It's very famous in all programming languages, and if most of the text type save like a string for the first time, and the second one is purpose. um, it's same as a string, but they have some extra details, and table, and as you can see, they're like that. Here is the emotion, and here is the text. For example, neutral emotion said that why it's neutral. Negative, on the way to my homegirl baby funeral. Kind of funeral can be negative as well. Such an eye, the true hustle, I, and so brilliant. Brilliant is again positive. And before again start, we should get familiar with one concept. It's tokenization. Um, we separate each of the sentences with its word, and if we want to see the example, it's same as like that. The documents and the terms. Here, tweets are our documents, and the terms are and word which are in tweets are our terms. For example, here, if it looks like a duck, comma, swims, and quack, then probably is. Here are terms, and each of these tweets that's now it doesn't show that are documents, and here they are the time that uh, these words are repeat as much as possible. For example, like repeated 3 times, repeated 4 times, or duck repeated 4 times. Such as data mining, we need to pre-processing in our text data. Every analysis need that. Here, for example, in text, we should write all of the text in capital or small version. Here, I prefer to convert all of them in small version. Words should be written by the roots. I mean, for example, eating, eats, ate, or eats. All of them convert to eat because they are all have the same meaning, just the grammar are different. We should eliminate punctuation, numbers, and proposition, and then we have the main part of our text. Here, we need to make our DFM matrix. Um, and for example, text one, text two until the end of our text. And here there are most repetitive word in some of our text. And as you can see, most of them are sparse matrix, and most of them are null. 99.98% of the words have frequency of zero, null. Because these words are not repetitive in all tweets. They just in text one, not the others. Using DFM matrix, although have has some pawns, it has some cons as well. It causes some issue. For example, longer tweets have more words, so in this way they have more impact on our analysis rather than short tweets. And the second problem that it causes, the repetitive words are less important in our tweets. But in the whole text, the repetitive words are more important. But in one tweet, they are less important. So we should consider all tweets, and in our prediction, they are not very important. So we should recognize that the repetitive word should have less impact on our analysis. So we were looking for the way that solve these two problems that we encountered with. It's none other than TF-IDF matrix. For the first issues that we cause, we create TF function, fric, divided to summation of fric. Here we solve the first problem that we have. Longer tweets have more words because now uh, long tweets and short tweets have the same effect on the on our analysis. Kind of they are normalized. And about IDF function, it's solve the second issues that repetitive war have repetitive will have less they are less important, so it decrease the impact of the repetitive war in our analysis. So it creates IDF matrix that we kind of give a reward to the to less repetitive matrix instead of having penalty in repetitive words. We get reward to less repetitive words, and logarithm decrease their impact. And IDF is normal frequently with counting reward in it. And As you can see, these are the things that I have said that TF will solve the first issue. It divided the considering number of word in tweets to all word of tweets. Thus, it won't be important to have long or short tweets. IDF solved second issue. We put some rewards to the words with low number and give logarithm to them to have less developments. I mean, less growth. Here are our TF-IDF in the function. We didn't use any ready function, and we wrote it ourselves. And here we multiple them. And here is our TF-IDF matrix. And as you can see, they got reward. And the other part, 96.3% of them are sparse. Okay. And the main analysis starts from now. Before that, you should get familiar with some kinds of concept. Here is our confusion matrix. Uh, the up of that is references, and here the prediction. A means that we really it really happened in the past, and we predicted correctly events. B means it's not didn't happen in the past, but wrongly we predicted that it happened. C is opposite of B. Really, it would happen, but we predicted that they didn't happen. and D correctly didn't happen, and we predicted again correctly. So A and D were predicted correctly, and B and C predicted wrongly. Sensitivity and specificity. The sensitivity is A divided to A plus C in here, and the one who did happen divided to the one which they happened plus the one which we predicted wrongly. But in the fact, they were both happened in reality. But our prediction were wrong in the C. And specificity is its opposite of sensitivity. And D divided to B plus D, the one who did predicted correctly that didn't happen divided to all of the events that didn't happen. And recall is as same as sensitivity, and precision. It's between the one who predicted that they happened, no matter if they really happen or not. I mean, correct or wrong. Which one are really positive? A divided to A plus B. So said that which one truly was happened and was correctly. Okay, we get familiar with three classifiers. First of all, base classifier, second SVM, and third one SVM linear. Here we get familiar with base classifier. It's analyzes dataset distribution in K classes, and in some cases is a very great way. And classes are all independent. Here is the formula, and they are most of them are independent. Sorry. We have the things, and we want to predict that which thing is it. It's the red one. Is it rabbit or thermometer or ball? It's the red tools, and we think that red tools must be. It's more likely than being ball or thermometer and rabbit. So it's kind of example of this classifier. Here is the code. Its accuracy is 70%, sensitivity 90%, and specificity is 13%. F1 81%, and recall 90%. Now let's compare this with other classifiers as well. Second one is SVM classifier. I don't really enter to its mathematical concept, but I tell you a bit about that. We want to maximize margin, and we move the line until the most correct classification. Here is the example of it. And there are some benefits that SVM classifier have, some pros and some cons. First of all, here we see that the classifier is like this, it's curve, and then it's convert to this. One of the most essential benefit of the SVM classifier is that we can increase our dimension. Here, our dimension is 2 dimension, and here is 3 dimension. And here we encounter with risk of overfitting, and here we don't. I don't know if you familiar with concept of overfitting, but I a bit talking about that. Here we can see that the our data sets are separate from each other correctly, but maybe one new data set come in, and it doesn't really infinite that puts in blue one or yellow one. For example, a blue data set coming and we want to predict it, perhaps because the complexity of model, the blue data set coming here, because it's curve and it doesn't really understand that. But here it's more, it's easier to recognize it. Some pros and cons of this classifier is that it's accurate and it has memory efficient, but disadvantage of it is prone to be overfitting, as I said, and no probability estimation, and it's not very good in big data sets. It's better in small data sets, but it doesn't mean that we can't use it. Here is our code. Accuracy is 74%, sensitivity 1, specificity 0, recall 1, again, same as sensitivity, and F1 85%. Here, until now, we can see that SVM is better than naive bias model. And here is SVM linear. Its accuracy is 34%. Oh, it's worse. And sensitivity 15% and specificity 88%. F1 25%, and recall is the same as sensitivity. Okay, now we want to decide which of classifier is better. First SVM and then naive bias, but honestly, SVM linear is not good. Some criterion that we consider, as I said, F1 balance accuracy, sensitivity, specificity, and accuracy, which is the main part of it. And I think it's the most important factor in our analysis. And here are my references.
Thank you so much with your nice presentation. You have any question, please unmute yourself and ask, or feel free to type them in the chat box and I will read them aloud.
Yeah, it's so great presentations. Maybe I missed, but the contents. But I want to know about which package you use for text mining. You mentioned to the ggplot for the plots,
Yeah.
but the rest of the conversation I don't.
Oh yeah,
Hear.
I perhaps missed that. ggplot and wordcloud was for visualization, but the main package that I used was Quanteda package.
Quantita? Okay, great. Thank you.
Quanteda, yes. I write it down.
Mhm. Thank you.
You know, you can use a TM package as well, but honestly, I got lots of error from it. But in internet said that you can use TM package as well.
And another question, how large of your data sets when you use it for data mining? Is any limited or you use very large? For example, you can data mine it from the one book or you have a limited for sentences and vocabulary number or something like that.
Yes, I think it has limitation, and you should be careful about the algorithm that you use. First, I really my algorithm were different, and I got lots of error about the RAM and it was very bad situation. I asked some other students and some mentors that they said that Windows is not proper tools for it, and you should work with Linux and some other things for big data, or maybe use Spark. So I decided to change all of my algorithm.
Thank you. So great. Good luck.
Here we have 34,000 approximately rows and two columns.
Okay, guys. Thank you, everybody. Thank you, Laya June. Thank you, Kiana June, for your
Thank
wonderful
you.
presentation.